Okay, so I just noticed that I did not finish this last problem. So it also wanted us to, determine the ratio of this acceleration to that due to gravity. So let's go ahead and do that. So my ratio is going to be AC over AG, and that's 4.6 times 10 to the 6 meters per second squared over 9.8 meters per second squared. Okay, and so if I put that in the calculator, I get 4.7 times 10 to the 5th. Okay, or we can say that AC is 4.7 times 10 to the 5th times the acceleration due to gravity. Okay. All right. So moving on to another example here. So this one says that we want to calculate the centripetal force now exerted on a car that has a mass of 900 kilograms. Okay. That goes into a curve of a radius of 500 meters with a velocity of 25 meters per second. Okay, so again, we're trying to find the centripetal force. Okay, so let me go to that page here. There we go. So my centripetal force is going to be equal to my mass. Now we need to pick an equation here. We don't have the acceleration off the bat, but we can calculate it, right? And let's see what else we have. We don't have the angular velocity, but we do have the linear velocity, v. Okay, so we're going to use this equation. All right, so we have 900 kilograms times my velocity, which is 25 meters per second, and we square that and divide it by my radius, which is 500 meters. Okay, so we end up with 900, times 20, squared over 500. We end up with about 1,030-ish newtons. Okay, so that is my centripetal force here around this curve. Okay, now for part B, we are wanting to find the minimum static, static coefficient of friction, okay, between the tires and the road. All right, so we can look at this free body diagram that they gave us, okay, in the problem, and this image. So we have some frictional force, okay, and we know that it is related to our normal force here, okay, and the only force in the, XY axis, the only force that is in the X direction is my frictional force, okay? In my Y direction, the only forces are my normal force and my weight. So looking at my diagram, I'm gonna say my F net in the Y direction is going to be my positive normal force minus my weight, okay? And that's going to equal to some mass times acceleration, right? But my acceleration in my Y direction is actually 0 since it's not moving up or down. There's no acceleration in that Y direction. Okay, so this tells me that my normal force is just my weight. I should say weight. Okay, just want to make that clear. Maybe I'll put bars on this. This tells me that they're vectors, okay? All right, so now I know this, which is just going to be m times gravity, right? Mass times gravity, okay? Now my frictional force, I'm sorry, I should look at it in the same, well, no, I can just straight try to solve for that, right? So my frictional force says that it's equal to my centripetal force, okay, or equal to my static force, or sorry, my static coefficient times my normal force, okay? So I can plug this in at least, this here, mg, okay? So now I have this side of the equation. I can now solve for this here, okay? So I can start plugging stuff in here, okay? I can say that equals either mv squared over r, or I can say that it's m r omega squared, okay? And that will be equal to my frictional constant here times m times g, okay? No matter which equation I use, my masses cross out, okay? And I have my velocity, right? And I have my radius. I could go a different route and solve for my omega, okay? But it's kind of up to you guys which you would prefer. I'm gonna go ahead and try it this way since I already have that value. Okay, so the first thing I'm gonna do is I'm gonna rearrange this equation one last time, solving for this constant here. It's gonna be v squared over g times r. Okay, so my v was given to me as 25 meters per second. Okay, square that. G is of course 9.8 meters per second squared. My radius was given to me as 500 meters. Okay, so let's see how this turns out. 25 squared over 9.8 times 500 gives me 0.128 approximately. Okay, so let me go ahead and check with the book and make sure that that is correct. Let's see if I can pull it up here. I think it was 6.3. Yep, perfect. So we've got it here. Okay, I just wanted to double check here. Okay, all right, so I'm gonna go ahead and you can go ahead and pause the video if you'd like, take a short break. I'm gonna take a bit of a break right now for a second and I'll come back.